Hello again and welcome. So, this lesson is about RHCSA, and we are going to talk about permissions and, in particular, about special permissions today. So, special permissions that means set user ID bit, set group ID bit, and sticky bit. And we'll be talking about access control lists as well. So, this is not the most advanced topic on the list, but I think it's interesting. By the way, thanks a lot for all showing up. So my name is Sander van Vught, and I hope you'll enjoy this session. Let's get started. So about permissions, if we want to apply permissions, it makes sense having an environment where we have some users that exist. So before we do anything, I am going to add some users and some groups to make sure that everything is working all right. So let me do some user add and create a user Linda, for example. Oh, we already have a user Linda. Well, that is fine. And then we probably also have user Laura already. Let's create two more users. Lisa should exist already, and Lori. So we have 4 users right now. So in order to set up real interesting permissions, it is useful to have some group accounts as well. So I'm going to create 2 groups, which is the group sales and the group account. And what I'm going to do, I'm going to set up a shared group environment. Setting up a shared group environment is an important skill on the exam. So when Red Hat is asking you to set up a shared group environment, they really want you to set up an environment where members of the group can write files to a shared directory. Typically, you also need to optimize such an environment, which means that you have to do something about the ownership of the directories, as you will see. We will get there eventually. But before going there, I need to set up some more basics as well. So right now we have 2 groups and we have a couple of users. Now, as we can see, there is this nice group mems command, and this group mems command is showing group members. So if I do group mems -g on sales and -l for list, we can see that the sales group has no members so far. And if we do group mems -g for account and -l for list, we can see that there's no group members as well. So let's do user mod to add some users. In order to do that, we need lowercase a, uppercase g. Lowercase a is to add and uppercase g is to manage secondary group accounts. So we are going to add user Linda to the sales group. We are going to add user Lisa to the sales group, and we also have an account group in which we are going to put user Laura and user Lori. And if right now we do this group mems command again, you can see group mems -g account -l is showing Laura and Lori as members of the group. There's another way of seeing group membership, which is by using the ID command. ID command is a useful command. If you do ID Lori, for example, we can see that Lori is a member of the group Lori and of the group account as well. Now, in order to understand permissions, the first thing that you need to know about, and you probably do already, but I'm just revising basics just to make sure that you don't miss anything. You need to take care of ownership. By default, if a user creates a file, then the user becomes the owner, and the primary group of that user becomes the owner as well. Oops, let me do a su dash on Lori. Did you see that difference, by the way? I typed su Lori and it didn't change the current directory. I do su dash on Lori and it does change the current directory. So we have this user Laurie, and if Laurie creates a file like a touch file and we do ls-l, we can see that user Laurie and group Laurie have become the user owner and the group owner of the file. Now this is a very important thing that you should realize before we can get deeper into the special permissions. Before we go there is one thing about the basic permissions that I want to show you. You may have already seen it. If you've been watching it, my video courses, I demo it in there as well. But I think it's important to be aware. So let's go to Home Laurie, and let me do touch root, and let's do su-Laurie, and we have ls-l, and we can see this file that is owned by root. And if I do an ls-ld, we can see that the Laurie home directory is read, write, and execute. So the interesting thing is, can Laurie or can she not remove the file that is owned by user root? Can I see hands if you think that she can? Wow, that is one hand only. Let's check. And as you can see, you can remove a file from your home directory even if you don't have write permissions to the file. What happened here? And I'm showing you this because this is something that is often misunderstood. Many people seem to think that you need to have write access to a file in order to remove it, but that is not the case. Deleting a file is a directory operation. So in order to delete a file from a directory, you need write permissions to the directory. And as you can see here, Laurie has read, write, execute to her home directory, and that is sufficient to delete files. Okay, for the rest of it, I'm just assuming that you know how to work with read and write and execute permissions. That's not the purpose of this session. In this session, I want to talk about the special permissions. So if we are talking about special permissions, the first one is set user ID, also known as SUID. So what is set user ID? Well, the word is meaningful because if on an executable file the set user ID permission is set, that means that the effective user ID is changed while running the file. To state it in another way, set user ID has you run a file as the owner of the file and not as yourself. Now, what does that mean? Let me do a demo. I'm creating a script in Laurie's home directory. And in this script, I'm making it a shell script, and I'm doing echo, hi, do you want to play a game? Read rm-rf/. Not the kind of game that you want to use every day, I guess. Let's do chmod +x on go. And let's become Laurie. So I am Laurie, and I see this nice new executable file in my home directory. So let's do /go. And hi, do you want to play a game? Well, as you have seen in this file, the core content of the file is rm-rf/. The thing is, if she would continue running this file, what exactly would happen? Well, basically, Laurie is just Laurie. So if Laurie runs a file that is trying to do nasty things to everything on the file system, she will do it with the permissions of the user Laurie, which means that she would wipe her home directory and everything else that is in a location where she can remove the file, and that is it. It doesn't mean that the entire file system is wiped. Now let's apply a little change and do chmod u+s on go. What is that doing? Well, that is setting the set user ID bit. The set user ID bit is on the user permission, And by using chmod u plus s on this file, the set user ID bit would be applied. And the set user ID bit means that at the moment that the file is executed as the owner of the file, which is root. So that would be pretty destructive, right? And that is also why set user ID bit is not typically a permission that you should set manually. If you set user ID bit manually, well, stuff risks going wrong. But the set user ID bit is a permission that is used by the operating system by default on many occasions. In order to find that, let's do a find command. Oh, by the way, before I move on, in this short explanation, I have shown you how you can use set user ID bit on a shell script, but the bash shell forbids files to run that have set user ID bit. So it was a very nice explanation to show you how it works, but it won't have any effect, even if I would be running it as user Lorry. Now, let's have a look at the files that by default have set user ID bit and that exist on your file system. I like showing you find to find out what exactly is happening. So if you do find slash dash perm slash 4000, that is going to show us a list of set user ID files. I'm redirecting arrows to the dev null device. I just want to see the files that have set user ID bit. So we can see all the files that have set user ID bit by default. And I can tell you, typically you don't ever have to change anything to these files. I am doing Linux for over 20 years now. I have never had the need to apply a change to the set user ID bit permission. Let's have a look at one of the example files that we can see here, which is userbin passwd. You may have heard of the passwd command before. Passwd command is a command that you are using to change passwords. If you are changing a password, the password is written to the etc shadow file. And as you can see, the etc shadow file has no permissions at all. If you do ls-l on user bin passwd, let's make that user bin passwd, then you can see that the passwd permission is marked in red and it has the S on the user execute permission, which means it has set user ID bit. So why do we need it? Well, when a normal user changes his password, the normal user needs write access to the etc shadow file. And that is why you want to set user ID bit on some very specific operating system files. So that's all I wanted to share about set user ID bit on files. Let's move on to set user ID bit on directories. We can be short about that. Set user ID bit on directories has no meaning at all. So let's take the next, which is set group ID bit. Basically, set group ID bit on files is doing the same as set user ID bit, but it uses the effective group ID and not the effective user ID. So if I'm doing find slash dash perm slash 2000, which is the command that is showing me set group ID bit files, I can see a short list of files that have set group ID bit. The message is the same, don't ever change it. It is needed by some parts of the operating system, but you don't ever should have to change this. Now let's talk about something useful, which is set group ID bit on directories. So what I want to do, I want to create this shared group environment, which is a directory data account and a directory data sales. And I want to do a ch own on the group sales for data sales and change own on the group account for data account. And if we do an ls-l on data, right now we can see that we have the two directories that are owned by the respective groups. So this is interesting, but not enough. We also need to do chmod g plus w on data star, for instance, to add the right permission to these two directories. And now you can see that members of the group have right access. Let's verify. If we become Lori and we go to data, again, Lori was a member of account, so we go to data account and we do touch hi, so she can create a file because she is a member of the group. And let's do ls-l, and then we can see that Lori is still the owner of the file. Now you may wonder if this is very useful, because this is a shared group environment, right? And in a shared group environment, it might be useful if all the other members of the group have right permissions to the file as well. As you can see that the user is Lori and the group owner is set to Lori, then all the other members of the group would access the file as others. And that is not very useful. And this is why you want to be able to set the set group ID bit on shared group environments. So how are we going to do that? Well, pretty simple. Let me go to the data directory first, and let's do chmod g plus s on star. G plus s is the command that you need to apply to get set group ID bit. And now you can see that there is an S on the position where you normally have the X for execute, and that would make it possible for the users to use it. So if I'm going to the sales directory and I'm doing touch of some file, you can see the effect immediately. The effect is that everything that is created in a directory that has set group ID bit will automatically inherit the group owner of that directory. So if we are becoming Lori again, and we go to data account and we do touch Lori file, ls-l, you can see the result, and the result is that Lori file is no longer owned by user Lori, but it is owned by group account. So we now have set up the account directory in the way that Red Hat wants you to set it up if you want to create a shared group environment. So the idea is that using set group ID on directories will inherit the directory owner to anything that is created within the directory, even in subdirectories. I'm getting a question here. Nice question. Thank you, Alexander. So the question is there any reason to set the owner of shared folders to anything specific? Here the owner is root, but sometimes I see owner is nobody in examples. I'm going to answer this question in my next topic, Alexander. So I'm just wrapping up with this, and then in the next permission, you will see that there might be a very good reason to set the owner to something else. Okay, let's go to hello, and yeah, that is a directory, and let's do touch hello and ls-l, and here we can see it even works for subdirectories. So set group ID bit is inherited through subdirectories as well. Now let me see on this group mems command 355 it is. Just wanted to check who are the other members of the account group, and you can see that Laura is a member of the account group as well. So let us become Laura, and let us go to data account, and in there Laura can see a couple of files. Now the question, can Laura remove these files, yes or no? Well, Laura is a member of the group account, and the group account has write permissions in this directory, as you can see here, which means that Laura can remove these files. So rm hi, for example, And it is asking, do you want to remove write protected, regular, empty file, whatever. This is telling that it is write protected. Write protected as in Laura has only read permissions on the file, because she isn't Laurie, she isn't a member of the group Laurie, she gets into the file through others, and that is why we are getting this write protected. So do we want to remove it? Yes, we want to remove it, and it is gone. The question is, do you like that? Maybe not, and if you don't, you need StickyBit. So what is StickyBit? StickyBit is a very interesting permission on shared group environments. If StickyBit is set on a shared group environment, only the user who is owner of the file is allowed to remove the file, or, and this is the answer to the question that Alexander just asked, the owner of the directory is allowed to remove the file. So Alexander just asked, is there any reason to set the owner of shared folders to anything specific? Well, if Laura would be the head of the accounting department, then she might be the owner of the directory, which means that she would be allowed to clean up the directory and remove items that she, as the boss of the department, doesn't want to have in the directory anymore. So that is why instead of using root as the owner, you might use the department chief as the owner of the directory. So if we go apply it, let's do an ls-l, we can see the account directory, and we are going to use chmod plus t on account to set StickyBit on the account directory. ls-l shows a nice blue color and a T because we have StickyBit. And if right now we are going to become Laura again, and Laura goes to the data account directory, and she tries to remove Laurie file, then she's getting an operation not permitted. And that is StickyBit. And this concludes the part where I'm talking about the special permissions. The special permissions, there are 3 of them. They apply to files as well as directories. There are basically just 2 scenarios that are really useful. Scenario number 1 is using set group ID on a directory, which allows for inheritance of the group owner of the directory, which means that anything that is created in a shared group directory is accessible by all members of the shared group. Scenario number 2 is StickyBit on directories. If you set StickyBit on directories, then only the owner of the item is allowed to delete the item. That's all so far. Okay, this is an off-topic question, Gianmarco, but I'm going to answer it anyway. It's about the last session. You have read somewhere at Red Hat that Samba plus Kerberos won't be present in RHCE due to a bug. That's somewhere. Do you have a specific link? If you have a specific link, Gianmarco, I would be interested in knowing where it is. Given the fact that Samba plus Kerberos is in the RHCE objectives, I just finished updating my Samba chapter with everything that needs to be done to enable it. But you are completely right that Samba plus Kerberos is currently non-functional. So because there's a bug, it is very unlikely that you will see it on the RHCE exam. Thank you, Gianmarco. If you want to send it to me, if you find it, I would appreciate that. So let's talk about access control lists. Now, what is an access control list? An access control list is a word that is very often used in IT. You can have access control lists on networks, on a proxy, for example. If you are configuring a Squid proxy, an access control list is determining who is allowed to access which specific URL. We are talking about file system access control lists here. File system access control lists apply to the file system. Now, why would you want to use access control list? Well, access control lists offer a few features that aren't available in the default Linux file system. So the first feature that is offered is that more than one entity can be owner of a file or a directory. By default, only one user can be owner, only one group can be owner of a directory, and you need to decide who is the owner, because everybody else will not be the owner. And that is why access control lists have been invented. In an access control list, you can create a situation where one user is the owner and another user can also get permissions to the file. And you can do that for groups as well. So if we apply that to our shared group environment, where we have these data sales and data account directories, access control lists make it possible to give the account group read permissions to the sales directory, for example, without passing through others. Let me show you. Right now I don't like the permission scheme too much, so let's do chmod o -rx on star, because we don't want others to have read permissions to these directories, right? So what we can do with access control lists is, as I said, make sure that one group that isn't the owner of the directory still does have read access to the directory. That is one thing. The second thing is the default access control list. Now, what is a default access control list? Default access control lists is about permissions that will be applied by default on anything that is created in a specific directory. Now, how does that work without the access control list? Well, we have umask. I'm root right now. Let me become Laura also and type umask. And there you can see that the umask consists of 4 digits. And basically, what you need to do in order to understand umask is to subtract the digits from 777. I'm just ignoring the first digit, because the first digit is for the special permissions. You don't want to apply any special permissions by default. So 0022 can be read as 022. It's the same. So what you see is that the user root has 022, which means that from the default of 7, nothing is subtracted for user, 2 is subtracted for group, and 2 is subtracted for others as well. Which means that if root creates a file, we have 755 on the files that root is creating. Now, did I just say 755 on the files that root is creating? You should notice that files is something specific. In Linux, a file can be a directory as well. On the Linux operating system, you will never ever get an execute permission by default on newly created files, which means that on new directories, user will have a read, write, execute. Group has a read, execute, and others has a read, execute. If the umask is 022, on files, the permission mode is 644. And that is because the execute is taken away. So the user will have read, write, the group will have read, and others will have read as well. As you can see, the umask for normal users is set to 002, which means that we get a default permission mode of 75 on directories the user creates and 664 on files that the user creates, which we have just seen, which is very convenient because it means that every user who is a member of the same group has read as well as write access to the files a user has created. Now, umask is useful, but umask is pretty static. That is, it is a user-related setting, and it means that it applies to every file that the user will be creating. And that is why we need something that is more flexible. And something that is more flexible is in the access control lists. We have the default access control list, and the default access control list means that you set default permissions to a directory, and those default permissions apply to everything that is created in the directory. Now let's have a look. The commands to use, we have get FACL to check the current file access control list, which I don't have yet, but it doesn't hurt to understand what getFACL is showing us. So it is showing us the name of the file, the owner, which is the user of the file, the group that is on the file, the flags, which is the special permissions, and we see the permissions for the user, the permissions for the group, and the permissions for other. setFACL is the command that you need to set it. For the exam, I would recommend that you have a look at the man page of setFACL because it contains some examples. This is the example that you want to be looking at. setFACL-M for modify, U for user, which can be a G for group or O for others. Then we get the name of the specific user or group, and then we get the permissions that you want to apply. So if you don't remember the exact syntax during the exam, read the examples. This also is the only example that really matters. You can do without the 4 specific cases in these examples here. Now let's do it, and let's create a situation where the group sales has read access to everything in the account directory. So in order to do that, we would have setFACL. I'm adding -R to make it recursive, -M to modify, G for group, and we have the sales and group, which will get read and execute on the account directory. So let's have a look in the account directory, and let's do ls-l, and do you see anything that we don't like here? Do you see that? There's an execute on lorry file as well. So that's not good. We didn't have the execute before, did we? If we do getFACL on lorry file, for example, we can see that this is messed up. You can see that lorry file is the file, and the owner is lorry, and the group is account, and user has read write, and group has read write, but there is this group sales that has read and execute. And do you see how this is represented by ls-l? That is because ls-l doesn't really understand access control lists, so it's messing it up. How can you find out? Well, you can see that there's a plus behind the name of the file. The plus means that an access control list applies. And if you see a plus, then you should not use ls-l to find out the current permissions. You should use getFACL to find out the current permissions. Let's do something else. Touch file 2, and let's repeat the command. And this time I am doing our uppercase X, and we go to account and ls-l, and file 2 has a plus, and if we do getFACL on file 2, then you see something very interesting happening. So do you see the difference between the lowercase x and the uppercase X? If you do a lowercase x in your access control list setting, files will get execute permission, and that is bad. If you do an uppercase X in the access control list setting, the execute permission is for directories only and not for files. Please remember this for the exam. It might be important. Now, this is very nice. We have an access control list, and the idea of the access control list is that the sales group has read access to everything in the account directory, right? Let's see if that works. So I'm becoming Laurie, and Laurie is going to the data account directory, and she is creating a new file. And let's do get FACL on Laurie file 2. And what you can see here is that it doesn't apply. So the command I have just used is for existing files only. That isn't very useful because in a directory, typically new files are created occasionally. And to make sure that on new files the access control list also applies, you need a default ACL. So what we are going to do, well, we are going to set it. And we are going to set it by repeating this command and making one little modification, which is the colon. The D stands for default. When you are working with setfacl, you should be aware that setfacl it is important that you specify the options in the right order. If you specify wrong order, then it doesn't work correctly. So you can do -D instead of D in front of the group or the user or the whatever. I like putting it all together by adding D colon so that I don't make any mistakes in the ordering. So if we go to the account directory right now, and I'm becoming Laurie again, and Laurie is creating a file in the account directory, and we do get FACL on that file, then we can see, excuse me, something went wrong here. Yeah, I see what went wrong. I'm stupid. I was being too fast. Did you see where I created the file? I created it in the home directory, which is stupid, of course. So data account. Let's do get FACL on dot first to understand what is happening. So what you can see is that a default user and a default group and a default group sales has been added, as well as the default mask. If we go check this new file that Laurie should create first, and we do a get FACL on this new file, then you can see that it does work. So what has happened? You can see that the user has gotten read-write. You can see the default for user is RWX, but on files you don't want to be applying the execute permission by default, so user has got read-write. You can see that the default group, RWX it should be, but the effective permission is read-write, and the group sales is RX, and the effective permission is read. Now, how come that the effective permission has been stripped from the X? That is because of the mask. The mask is applied automatically to all files to filter out the execute permission. So the result is that in the default ACL, you will never ever get execute permission on newly created files. Now, if we create a subdirectory, and we go to the subdirectory and we do Dutch file in there, get FACL file, you can see that it still works. It works in subdirectories and everywhere in the file system tree that has been created here. And this is basically how you set up a directory for ACLs. ACLs that allow one group to access files in a directory that is owned by another group. Let me resume this. We can see here ls-l that the account directory has a plus, so the account directory has ACLs, the sales directory has no ACLs. I just want to resume the basic things that you need to know in order to make this work. So what we are going to do first is not get FACL, set FACL. We are going to take care of all files that are currently existing. So set FACL -r-m g : account colon RX on sales. This is not enough. Right after that, we are going to take care of new items that will be created from now on. So basically, if you want to work with access control list, you always have to apply two commands. One command that takes care of currently existing items and another command that takes care of newly created items. This is something that often goes wrong. And if you don't do it twice on directories, you will forget stuff. And if you forget stuff, that will cost you points on the exam. There's some other stuff I want to show you. Let's do set f ACL -r -mg blah rx on sales, which is giving me command not found, which is understandable. And there we are getting this very interesting error message, which is invalid argument near character 3. Yeah, right. What it means here is that I'm using a group that doesn't exist. I don't have a group blah, and I just wanted to show you that if you get invalid argument near character 3, then probably you have a group that doesn't exist, or a user that doesn't exist, or anything. Something else that I want to show you is that on previous versions of Red Hat Enterprise Linux, there was this ACL mount option that needed to be specified. That is a lot of information. Let me do mount pipe grep dev to see my current file systems. We only have XFS file systems. Oh, we also have an ext4 file system. On previous versions of Red Hat Enterprise Linux, all the file systems that were created manually after the installation needed to be modified to have support for access control lists. On RHEL 7, this is no longer the case. Access control list support is present by default even on newly created file systems. Let me do tune2fs on the ext4 file system. Tune2fs is a very useful utility, but it works for ext4 file systems only. -L for list on dev mapper vg whatever, and pipe that to less, and then we can see the default mount options that are set to user extended attributes and ACLs, which is cool. So they work by default, and you don't have to do anything in the FS tab or using other mount options anymore. Now we have 15 minutes left, so let's do something funny, and let's talk a little bit about user extended attributes. You may have noticed that if you do, now let's do it on a different directory, on the etc directory. If you do ls-l on any directory in Linux, you may have noted that there's a dot behind the permissions. The dot is there because the file has user extended attributes. If you do an ls-attr on yum.conf, for example, ls-attr is showing the support for current user extended attributes. So this is funny. There are no user extended attributes on yum.conf. We just have the option to support them. Let me show you how it works. I'm going to the root directory, and I have this server1.keytab file. And no, let's not do it on server1.keytab. Let's just do it on the AA file. If I do a chetter plus I on the AA file, and I do rm-f on AA, I'm getting an operation not permitted. So why is that? Well, that is because of the user extended attributes. User extended attributes, by the way, this is not a topic for the RHCSA exam or anything, but it's an additional way that you can use to secure your files. If you do man on chetter, you can see what you can set using the change attribute command. And this is a list of all the attributes that are existing. I particularly like the immutable attribute, because the immutable attribute is an attribute that prevents users from deleting the file by accident, which can be quite cool. And there's a couple of other attributes as well. And I just wanted you to be aware of that. Now, again, CHAtter is not something that you need to do on the RHCSA exam, but it's nice to be aware. Which basically brings me to the end of the session.